Thank you, Stan, and thank you to all the organizers for inviting me to this very rich and intense day. So please, could you show my slides on the screen? And because I'm the last speaker and we have some late delay, so I really count on your empathy to maintain an active consciousness during this last talk, if you are able to. Yes, thank you. So please, yes, my slides. And I will actually, my talk will be very complementary to the first half of Stephen's talk, because I will try to focus on the patients with disorders of consciousness. So maybe he's already sleeping there. In this, and I try to play the game of the conference today, neurotechnology, and trying to focus on the use of neurotechnology in the clinics. So I will present you only some clinical part of my work about these patients. Stephen talked about the patients in disorders of consciousness. And I think we can open the discussion, but in this case, for me, there is no way that the neurotechnology use is worth, it does worth it to use it, because it provides very important added value for the clinics with ethical implications. So I will try to illustrate that for diagnostic, so the interest of neurotechnology for diagnostic, for prognostic, and for therapeutic tools. So typically, as Stephen showed you, and it also going to your question, Stan, it's a typical trajectory of a patient. The patient was in his 20s. I can tell you a little bit about him. In his 20s, very happy life in every domain. And then he fell from a building a Saturday night with friends. They were drinking some beer. He fell from a building. He has severe fractures, not of the brain, but with fat emboli in the brain. So you can see here that 3 hours after the trauma, actually, he fell into comatose state. And he stayed in the comatose state for almost 2 weeks. And then, like Stephen showed you, he began to open his eyes without intense external stimulation. That's the definition of moving, going out from comatose state. But in this state, vegetative state or unresponsive wakefulness syndrome, the patient only showed reflexive behaviors, no sign of intentional or self-awareness. Of course, it's very difficult to completely be sure of you if you have only behavioral analysis. And then, after more than 1 month, the patient began to have visual pursuit, typically, like Stephen told you, so move to the MCS. And then after several months, he get back to functional communication. You could collect subjective reports, subjective experience of the patient. So, of course, for the clinical criterion, he will move to a conscious patient. But as you can see, the typical clinical neuropsychological scores were very impaired for memory, executive function, global cognitive function. But still, after 1 year, he was back to home, back to business, new friends. Only his girlfriend left him. But I met him 2 weeks ago, and he recovered a very happy life. And of course, it's a short digression. But when we were called to explore this patient at the Salpêtrière, actually, it was during the red curve, the vegetative state period. And seriously, our colleagues were discussing up to which point will we go for the active maintenance of active therapeutic in this patient. So typically, what you want to do with neurotechnology is not to miss this kind of trajectory in which, and I don't say these trajectories are the case for everyone, but still we need some added value to go beyond behavior. So you recognize this Babinski and Charcot. It's not only because it's Paris, it's at the beginning of behavioral neurology. And as Stephen showed you, we have this, so I will go fast here. You have comatose state, so let's say abolition or severe impairment of vigilance, comatose, deep sleep, or general anesthesia. And then you have these strange cases in which you can have a minimal level of vigilance, which recovered, the patient could recover, but without any sign of conscious, as we could say, functioning. This is the case of reflexive behavior of vegetative state, and the name can be discussed. As you know, vegetative state is problematic because it's very pejorative, but actually the intention of Jenner and Plum was not to say the patients are like vegetables. It's to say, like in neuropsychology, dissociation between preservation of vegetative nervous system versus abolition of cognitive life. So that was the intention of the word, but still it's a problematic word. And then this minimally conscious state. So I would like just to take 2 minutes, because if VS, vegetative state, is problematic to explain to people, to society, etc., I think that minimally conscious state is also problematic. So why is it problematic? for the following reason. So to say that a patient is in a MCS, minimally conscious state, we use this very powerful clinical scale designed by Joe Giacino and colleagues. It's a gold standard. It's a very good scale, clinical scale. I will not develop it, but typically it's a hierarchical scale with different subscales, auditory, visual, etc. And you have some items that would label the patient as being vegetative state, only reflexive behavior. But for instance, in the visual function, as soon as you have visual pursuit, you would say the patient is not vegetative, is at least MCS. etc. And as soon as the patient has one MCS item, he will be labeled as being MCS. And to be very clear, this scale is super important, meaning that the diagnosis, the prognosis emanating from this tool is very high, very powerful. But still, the problem is what? Is the name of the state. So because we call it, it has been called minimally conscious. So of course, when you say to relatives of a patient, minimally conscious, of course you said the adverb minimally, but you said conscious. And of course, in this very tragic situation, the families would say, okay, he or she is conscious. And the whole point I want to make is that actually, of course, some of these patients may and are conscious, but it's not the case for all patients. And why so? Because as I told you, if you have only visual pursuit without any other MCS item, you will be labeled as being MCS. So when you go back to the scale, actually, this scale is very important, but is misnamed because what we do when we perform the CRSR and we say a patient is MCS, actually we don't know if the patient is conscious because in the scale, as soon as you can have functional communication, you can collect subjective experience. Of course, the patient is labeled conscious. But when he doesn't have that, you don't really know. So I think calling the patient minimally conscious is very ethically problematic. And the problem is that actually it's a very powerful scale because you can be sure of something. Is that the behavior you observe require cortical contribution. So all the MCS items say only one thing. Observation of behavior demonstrates that you have cortical networks playing a role in the behavior. And that's a massively important information, but it's not equating to being conscious. And not to be too long, you know, in French you match the adjective with the name. So every time we have a new student, I pay attention, how will he or will she write état de conscience minimal? Will minimal be accorded to état, to the state, or to conscience, to consciousness? And actually it's half-half. So actually we don't know what we mean when we say minimally conscious. And it's a shame because the scale is fantastic and the information is precious. So we spend a lot of time with families, relatives, colleagues to explain them the meaning because it's a very powerful meaning but misnamed. So I wanted to make this declaration. And actually, with Bertrand Herrmann, we try to explore this hypothesis. So we said we did something like that. You take the visual subscore, you take all the patients who showed for this subscale the VS item, the red, none or visual startle, and you compare FDG PET activity, so brain metabolism, like Steven showed us, for the visual MCS. So you could say, if MCS is really MCS, maybe I will see Steven's frontoparietal network. But actually, when you compare what happened in the brain of patients who are MCS only for vision, you see only visual cortex, not the whole anterior-posterior. When you do the same for motor MCS, you see only a cortical motor network. But if you go to response to command to auditory, then you begin to see a much wider frontoparietal global workspace network. So just to say that we tease apart and we have a very crude term to mix together patients who do not share the same status. And even by saying that, you see already the importance of using neurotechnology to go beyond the mere behavior. So what we can do, we can try to, so I will of course be schematic, we can probe conscious access. So you will stimulate a patient with external stimuli, and you will look for brain responses to the stimulus. And I will show you just one illustration. So for us, it's a kind of a dogma because it's an old test we designed in 2009 with Tristan Bickenstein during his postdoc. I will not describe it in details, but what we do, we use series of auditory tones, and basically we define two kinds of novelty, either an intra-trial novelty, for which you do not require to be conscious, only your perceptual memory, mismatch negativity system, which was mentioned this morning, are enough. And then when we do that, we can see indeed that with scalp EAPs, you have the blue circle anterior midline, which is a mismatch negativity around 130 milliseconds, followed by anterior positivity, and then nothing. With fMRI, we could confirm, it was not a discovery, but that MMN local effect is coming from auditory areas, so from a cortical region, not for the whole, from the whole frontoparietal network. And when we use, like Florian showed us, and also Joseph, intracranial recordings in epileptic patients, we could, with Imen El-Karoui, record MMN from intracranial data. It's coming from auditory area, so it's okay. But then we defined an intertrial regularity, like a rule, which would require you to keep in working memory, if you have a working memory, a conscious working memory, the nature of the rule and identify violations of this rule. And in this case, that's what we call the global effect. Now you record a P3B when you look for brain response to the global novelty. And nicely enough, in terms of temporal window, you see on the top the local effect. It does not match, it's not overlay with the global effect. So you can tease apart the mismatch from the late conscious access proposed neural signature of global regularity. And again, when you do that in fMRI, this time you do not have only auditory areas, but the frontoparietal network, the global workspace network, and with intracranial recordings, you record activity from prefrontal cortex, for instance, or so you can use this global effect. Of course, it's useful because it can be very specific. You would say if a patient shows a global effect, it means that he can be conscious of a global variation, so he is conscious intransitively. But of course, if you miss the effect, you cannot say much. You can be still conscious intransitively, but without being conscious of the rule for many reasons. So now we recorded more than 500 patients, and typically it's what we did with Frédéric Faugeras more than 10 years ago. You have on the top a normal volunteer. So if we would record the local global effect for each of us now, and you play the game, you pay attention, each of us would have a significant global effect. So it's working in all conscious subjects who are conscious of the violation. And we played a lot with that. But then you can see some patients. In the middle, you have the first VS patient with a global effect. We reported that in neurology in 2011. And 3 days later, the patient moved to MCS Hyperion and MCS Plus. So for us, it was a sign that the patient actually was in a conscious state, but it was subclinical. You could not see it only with the behavioral measures. And of course, you can have patients who lack this. So now, with Pauline Perez, we could see that actually it's a very specific but loosely sensitive marker. Only 50% of patients who are conscious do show it, but it's a very useful hit because it means that if you have a patient with a global effect, if the behavioral scale, like Steven showed us, and I show you CRSR, is VS label, you have to question that. The patient is not in a VS. It's a CMD, a cognitivo-motor dissociation, or whatever. So we can also adapt this global effect to pupillometry, so using an eye tracker and pupillometry system with Marion Quirin, Saud Sangaré, we could show that you can begin to collect this effect at bedside on ease with pupil dilation, global regularity, to violations of global regularity. Okay, and in this perspective of using technology, actually, with Stanislas, with other colleagues, we developed this global neuronal workspace for 2 decades now, and we can play with neural signatures of conscious access. And the P3B I showed you actually seems very similar in the auditory modality, but also in the visual modality. The spectral power signature of conscious access seems also to be similar. The functional connectivity between distant areas in the late time window seems also to be very consistent across sensory modalities. And a method developed by Jean-Rémy during his PhD with Stanislas, the time generalization method, with this diagonal ballistic pattern followed by a square-like maintained similar representation in a late temporal period. So we can begin, and that's what we do in the clinics. We collect these measures for each patient to see up to which point do we identify in this patient signatures of conscious access. Okay. I realize that I forgot to tell you something, I'm sorry, because I told you that MCS was not a good name, you remember? But I proposed to replace it by another word, and I forgot to tell you what. So MCS, you could, because it's not a minimally conscious, you can see if you want to keep the letters and to make the anagram of this acronym, I propose CMS rather than MCS. CMS for cortically mediated state. So when a patient is MCS is not MCS, he is CMS. He is in a cortically mediated state. I can say that 100% sure. Maybe he's conscious, I'm not sure. That's it. So another thing we do in the clinics that we use EAPs, but this time to use the response to command task. And my close colleague Benjamin Rowe, when he was working in the Jan Klassen's lab at Columbia University in New York during his fellowship, and Jean-Rémy was part of the story too, they could produce an SVM, so a machine learning basic algorithm, in which you decompose spectral power of EEG in the next 2 seconds after a verbal instruction. Move your right hand, move your right hand or left hand, or don't move. And you try to see if you can decode move versus not move instruction. And what they found is that actually, so this figure is a double dipping, just for a representative picture. You can see in yellow the decoding performance on a run in conscious volunteers. So up to 6, so the first blocks are move and then don't move, move, don't move. And you can see patients, the average performance of patients with a significant response to command with EEG in blue and without in black. So we can use also this new brick, and you will see that we will collect all together, and that's what we do every week in the clinics on the model of what Stevens developed in Liège. So I think this kind of expertise group are very important. And that's a new study, not yet published, a poster. Nico Schiff coordinated this GSMF Foundation with Steven, with me, with colleagues in London, in Cambridge, UK, also two centers in the US, 1 center in Canada. And basically, to make a long story short, you have more than 500 patients, fMRI or EEG, response to command task. And you find this number, which is almost the same I showed you for the global effect. So the patient who do not show response to command on the behavior, VS or MCS minus, EMS minus, whatever you want, almost 1/4 of them do show response to command in brain activity. So this is a very convincing argument to say we need actually the neurotechnology to assess these patients the best we can, because Steven showed you that also maybe very fast. What I talk about is about patients that are explored behaviorally, let's say a perfect way. But when patients are referred to us, already there is 30% error in the behavioral observation. But then when you repetitively observe and make the examination, neurological examination, CRSR several times, then you still have this on the top 24% of patients who have response to command, but you cannot see it in the behavior. So we can probe conscious access to various stimuli, but you can also probe conscious states with neurotechnology. And I will be very brief, very synthetic here to keep some time. So that's the model, you know, the global workspace. And based on this model, we propose with Jacobo Sitt, Jean-Rémy, Stanislas, a whole team, we propose some neural signatures of, let's say, do you still have a conscious global workspace characterized by long-range connectivity in certain frequencies? So it's a WSMI in the theta range I will not develop. So in yellow, high-density EEG, you see the value of connectivity between 2 areas, 2 sensors, let's say. I don't give you the cooking recipe for that. And then when you move to conscious MCS or VS, you see a massive disappearance of this long-range connectivity. And you have this posterior hub, similar to the region also mentioned by Joseph and by Steven, this posterior hub of connectivity, precuneus, singular posterior, etc., posterior cingulate. And that is also lacking when you take the VS patient. The same story for the complexity. You can compute the complexity of EEG with various algorithms. And again, according to what is not only our theory, IIT or other theories predict that you need a complex mode of processing to be in a conscious state. So you can quantify that for each patient. And the nice thing is that you can take all these markers together, and we published that in Brain in 2014, almost 10 years ago. And we replicated that, and many groups replicated that. So you can train an SVM, for instance, a support vector machine learning algorithm. You feed him, for instance, with 200 patients, 100 very well-defined VS, 100 MCS. You provide the machine learning algorithm with the 20 best markers, complexity, connectivity, global effect, etc., spectral power. In this hyperspace, you locate 1 point is 1 patient, and you train the algorithm to optimize the discrimination with a hyperplane in this space. And what we observe is that you end up with a EEG decoding diagnosis. Is the patient MCS or not? And with the predicted probability. So here you have this thermometer. The bluer you are, the more probability you have to be in the MCS state, and you were classified by the MCS. And to see the utility of this measure, in the first study, I showed you only this result. We had 75 patients in a clinical VS, behavioral VS. 2/3 of them were classified as VS by the EEG, but 1/3 of them were classified as MCS. So to see what was happening, we followed the patients, and the proportion of patients who improved was doubled in the group, which was EEG MCS, behavioral VS, as if your algorithm could capture something you cannot see in the behavior. So that's one of the best for us argument to use it. We make the replication with Denis Engemann, Federico Raimondo, showing that even if you take 8 electrodes, not the 256 that we use, and only 1% of the time of the recording, you almost have the same AUC to distinguish. So it can be a very massively distributed tool for ICUs, for medical structures. I will go to another thing. Usually people think that neurotechnology will go beyond behavior, but you can do the reverse. You can use neurotechnology to improve your behavioral observation. And I will give you just one of 3 examples. More than 20 years ago, I made this observation that when you look for the auditory startle, so you clap in your hand and you will have an eye blink for the patient, you have 2 types of behavior. You will see that. I think the audio video is a bit delayed. You see, for this woman, the patient is the reflex is irrepressible. There is no habituation, no extinction. And on the contrary, in some other patient, I could observe something like that. We published that with Bertrand Herrmann in Brain. Extinction of the reflex. It's not that the patient was deaf, you have the initial reflex. And my intuition was maybe when you have this inhibition of this repetitive, meaning it could mean that you have a working memory playing, understanding the rule, inhibiting the reflex, and the prediction that maybe the patient would be in a better state, richer state. If it would be the case, it would create a new basic clinical science that you could do everywhere without technology. And what we did is that when you compare the patients who have an extinction, so habituation of the reflex, most of them in blue are MCS. So it seems to be mostly for MCS, not so much for VS patient. And funny enough, when you compute the AUC of this new sign, with no circularity, because it's not in the CRSR scale, it ranks second across all the MCS items. So it's a very powerful new item to identify MCS, but it's not in the scale. And when you compute the EEG, you see that you have an increased long-range functional connectivity when the patient has this habituation. You have an increase of multimodal SVM probability of being MCS. When you are in blue, you have the habituation. You have an increased metabolism in the frontoparietal global workspace network. So basically, in the end, the last paper with Joe Giacino, and I'm part of this paper, in the Curing Coma campaign, we could validate this sign as a new behavioral sign. So you can use neurotechnology to enrich the repertoire of clinical observation with a stronger interpretation. I will show you that. A patient, severe TBI, we could examine him, it was during the COVID, back from the US, and the patient was MCS. We could make the auditory startle, extinguishability. We could make the global effect, you see the red versus blue curve, he had a significant global effect. We could see the complexity, connectivity, you see the high MCS multimodal diagnosis. We could see the motor response to command, the New England paper of Benjamin and Jan Klassen, he was significant. So we collect all this data together, and we could say the patient is most probably conscious, and hopefully he could recover, and the patient could recover. Sorry, maybe you have to launch a movie. If you could launch a video, you have this eye tracker that we are using now. Thank you. You have just to play. I did not launch automatically as I did. Oh, thank you very much. And you see, with eye tracking, no doubt that the patient is now foveating and even reading. I'll let you see. So you are in the patient's perspective now. And now is he reading? You have the pupillometry data below, and that with Aude Sangaré, and he's have a very smooth visual pursuit of a visual target. So just to say that the way you can combine all these neurotechnology markers to better enrich the state of the patient. So I will close with a last study which is under revision. Is this information, which seems to be important for diagnostic, also important for prognostic? I told you the MCSVS seems to be very important. We have a lot of studies now. What we did with Benjamin Rowe and Charlotte Caligaris, we reviewed all the patients that we saw, so 500 patients. And then for each patient, we make a description and we propose a prognosis. And the prognosis is either bad, good, or we don't know, uncertain. And the scale we use is a Gauss extended scale. So basically, we consider it's not only on that you take any decision, but we propose a prognosis that the Gauss superior or equal to 4, meaning that the patient can remain at home alone 8 hours and he is conscious, is the green area. And when the patients are in more severe states, they are in the state is dead, vegetative state, or you have to be, patient needs consistent, permanent assistance. So we have these three outcomes. Good outcome, bad outcome, or we don't know. What we could see is that we have the outcome of the patient 1 year after the prognosis being emitted. And you see here when we said it's a poor outcome, none of the patients had a Gauss outcome scale superior to 4 or equal to 4. So we did not miss, in this series at least, a patient we could recover. When we see the uncertain, we said we don't know, we cannot make any prognosis. You can still appearing some good prognosis patients. And when we said the patient, we propose a good prognosis, you have a much larger increase of better prognosis, but still, it's an ethical discussion. You still see patients with very severe state, okay? And we enrich this study by removing the patient for whom there was a withdrawal of life-sustaining therapeutics because you don't want to be in a self-fulfilling prophecy. You don't want to say, bad prognosis, so limitation, so the patient is dead, so it's a bad prognosis. So you remove these patients, and still, even you enrich the quality of the prognosis. So meaning, it's just to say, it's not to say that we are good, because actually we trained an algorithm to do like us, and you can train an algorithm, like, to go back to Stephen's point, what were we for? Just to say that there is an added value for the prognosis of this patient. And the last result here is that across time, in Abscissa you have the time, and across time, it's not only that we increase our expertise, but we increase the neurotechnology. You see the arrows, EEG, ERPs, 4-scale, resting state fMRI, quantitative EEG, fractional anisotropy, etc., PET scan, etc. And what you see here, that's the last curve here, if you take the number of exploration which were done for a patient, so when you have 1, 2, 3 exams for a patient, you have, let's pay attention to the top curve. So the accuracy of the prognosis is 60% when you remove the patient for whom we said we don't know. So you take the good and bad prognosis claim, and you see the accuracy of this claim. But when you move to 8 to 10, you are almost to 90%. So it's not only an effect of time, it seems that really you can reduce the uncertainty of prognosis. So we propose with our French colleagues, Jacques Lyoté and Stein Silva, Jacobo, Benjamin, to offer a structuration of this expert offer to a country scale, because you don't want to have only 2 patients a week. You have plenty of patients in all countries. How do you do? So we propose, I will not develop it, I can share it with you, 2 tiers strategy in which you have access to a minimum number of neurotechnology everywhere in all clinical structures with CRSR, distant servers for EEG, quantitative performance, maybe also for MRI. And then if it's not clear, or rare etiology, or these mismatches between the exam, you call to regional center, like the one of Stephen or my center, and then you try to see if you can better increase the number of exploration, etc. I will not develop that. So if I have last 2 minutes for therapeutics, I will go fast, because Stevens also paved the way with, for instance, the TDCS. So you have a lot of tools today, from the most invasive DBS, of course, and this morning the optogenetics or sonogenetics also could be a very good and ultrasound with mechanoreceptors. And then you have vagus nerve stimulation, and then you have TDCS or TACS. And this one is, of course, less invasive. And we had this study with Bertrand Herrmann, in which we could see It was an open label, no sham, no double blind, but we could reproduce the same proportion of responders. So 20% of responders, 12 patients, you see their improvement. No one degraded, so really think that it's either a placebo effect or a genuine effect. And nicely enough, when you compare response, the markers of consciousness we propose for responders as compared to non-responders, you have an increase of functional connectivity, you have an increase of late window earpiece to auditory novelty, you have an increase of complexity. And the last result, which seemed for us very promising, is that when you take patient T1 MRI anatomy, and you try to model for each voxel the intensity of electrical field induced by the TDCS, you end up with a series of values of this intensity across patients, and you can correlate, are there some voxels, the intensity of electrical fields they have been stimulated with is correlated with something, and it's the case, it's correlated with improvement. So you can see here the red areas are the ones which are correlated with improvement, and no voxel was correlated with degradation. So really suggesting that it's a genuine result. We replicated it in preparation with a double-blind sham control with Haute-Sangaré, behavior and EEG and modeling of neural sources. So I think the tomorrow, immediately tomorrow, no science fiction, immediately tomorrow of TACS or TDCS is to do the reverse, is to begin by this exploration of the patients, to identify those patients we could benefit from that, to identify the brain location which would optimize the stimulation of preserved global workspace structure, and even to use, I spoke about TDCS, but if you use TACS, you can use the proper frequency of the patient when he's stimulated with stimuli he is aware of, trying to stimulate spatially and frequentially, optimally for a patient to increase his conscious state. And I think I will stop here, and I thank you for your conscious attention. Thank you very much.